Hello everyone, welcome to another SUPboarder video, or two videos in fact, where I'm going to be diving into a behind the scenes chat to Red Paddle Co. Going to be speaking to commercial director George Shillito and head designer Phil Hawthorn about all things Red Paddle Co. We're going to split this into two videos because there's a lot of information in here. The first video, we're going to be talking about the production process, the quality controls, the MSL material they have, and we're going to be speaking about welded versus glued rails, so their tech air process. There's going to be a lot of very interesting information in this video, and in part two I'm going to be diving into what do Red do very differently from other brands as well, so definitely check out that one afterwards. So let's talk basics first. How can you make an inflatable paddleboard?
Well, inflatable paddleboards are made out of something called drop stitch. Drop stitch is the manufacturing term for when you're weaving on.
I saw something, got loads of interesting, look at that.
Well, this is a drop stitch.
Yeah.
Okay, because the machine drops a stitch. Okay, and it connects two pieces of material, 1, 2, with the drop stitch. Okay, so this is the common material at the minute to make an inflatable paddleboard. When you get the material, it comes on a roll because it has been woven. It comes off a big machine, it's rolling. It can come in a flake or a roll. Okay, a flake is when it's just folded over like a pastry. Okay, we cut a board template or a shape out, and then you've got to make that material airtight. Okay, so we add a tape around the shape. That makes the unit airtight after we've added a valve. And then we've got our basic fundamental modern day inflatable paddleboard.
And obviously there's many different qualities that a brand could be making, as in their manufacturing quality to making the same thing, isn't there?
Yes, yes, definitely. I mean, we specify the exact materials, the grades of materials, the densities, the composition of those materials, because we used to originally in the first prototype stage just buy off the shelf, but the materials didn't perform how we would have liked. They either weren't stiff enough. In production they shifted, they moved, because you've got to remember materials are material. It's not like working with a block of steel or a piece of wood where you're turning it on a CNC or lathing it. This is a technical fabric that moves in 3 different directions. So they've got to perform. They may expand, they may compress, they may shift, they may twist. There's so many different things. And so we quickly found that we needed to control that and set that, because otherwise we didn't know what we were getting. So we've been quite fortunate, because over the years we've had time to learn about that and tune it and spec it exactly how we want it.
Because definitely that is the biggest thing, isn't it? There's materials, and then there's knowing exactly what the material is.
Yes.
And this is something that we've spoken about in other videos and in the past with you. You guys really work at knowing, like you just said, what's going in those boards.
Yeah.
Because is it true in some factories and some brands that they would have changed materials and their brand doesn't even know about that? The factory might have changed the material.
Definitely. Yeah, definitely. I mean, because it's happened with us. We are no different from any other company in any other industry. If you don't have a good relationship with your suppliers, and you don't own the space where we are now, we're not making the board here now, you don't have visibility. They could change something, which is why it's so important that we have such a good relationship with our suppliers. Because there could be a case of they change the material because it might be cheaper. It might not have been available that month because their supplier has had an issue further on up the line, and they've just put something through because they thought, oh, someone's not going to notice. And it does happen. It does happen. It happens in every industry, every sector. So that's why we're really lucky, because we have visibility. We visit them regularly. We talk to them daily. It's
and also,
good.
I think they've got, from my understanding and listening to you, you're on it if you're on their back basically if something got changed, because you
Yeah, we used to be a bit more on their back, but I think over the years, as I said to you earlier, they're just another department. It's like they're next door because all our manufacture is based in Asia. But because of that relationship, they understand what we're trying to do, and our suppliers equally want to be that premium supplier because you want to be the best in your industry. You want to do the best that you can do and offer the best that you can offer, and they get that, and they get that. That's what we want as well, and together, it's got to a stage now where there's certain things that we don't have to look for because we know it's already covered. Whereas there's other things that we both together need to look at and review, and just like you said, constantly. It's never ending, but yeah.
Remember when we have spoken about it as well, if you write the specification for something, then you know what you're testing against in terms of quality control. Whereas if you don't know what you're testing against, then there is no point in doing the QC. And when you're coating a material in particular, the inconsistencies that can occur in terms of a coating of a material, I think that's the biggest area of why we go into such detail in terms of all the way back to raw material stage and specification, is to know what we're trying to test against and what our QC level is to be able to put the red brand on it, because otherwise you just have to take word for it. And like Phil says, stuff happens, things happen in the supply chains the whole time.
All the time.
You can't account for it.
And I think that's the thing is we were quite lucky to get to the industry quite early, and there was no rule book. It's like raising children. There's no rule book that says this is the right way to do this, this is the wrong way to do this. So we were quite fortunate. We made a lot of mistakes very early on. And I think that's where we were quite fortunate because there was no rule book. So we wrote our own. And it's those standards that we can measure against and work towards. And they are always, they're living documents. They're always evolving and growing. And because there's no one that comes and marks your homework. There's no one that holds you to account. And I think that's what it definitely separates us is you want to be the best you can be. So
because definitely there's a lot of words, terms, myth-busting things that need to go on. You know, whether it's like single layer, double layer, fusion, drops. Obviously, drop stitch is an easy one, but you know, welded, electronic. I don't know. You can put a name to any different sort of. You know, and like the basic one. So in the past, it was single layer, double layer, which is the 2 layers of PVC, and now there's a sort of the melted sort of. Is it 1 layer? Is it 2 layers? How thick is it? You know, all this sort of stuff. So where are your paddleboards and just in terms of now with the top laminates, you know, because a lot of people are raving about single layer and double layer, but you guys have how do you rate? Do you have a certain thickness, or just looking at the layer?
We have a certain configuration, which lives in my head. But it, I mean, obviously there's so many different acronyms, and companies can put different spins on things and trademarks and names and technologies, and we've got single layer, which is the material, the woven or the knitted material. The textile, the textile, and then
the actual material where the drop stitch comes through.
It's like a bed sheet. The actual material, is woven or knitted, whichever one you decide, and then you've got to make it airtight. So you'll put plastic over the top. Okay, that is what was commonly referred to as single layer. Yeah. Okay, right. So then there's no structural membrane to that. It is literally just a material with plastic on top. So then what we or the industry did was you added a second layer. Now the second layer is another material, another bed sheet, woven material, coated again, but that's got strength, okay? Because if you used a woven material, you'd have the warp and the weft. So that the fibres that go up and down are the fibres that undulate and go from left to right. Okay. Now, if you add that material onto a single layer material, the one that I just said that's already been coated, you have to glue it. You glue on top and then you stick that material there. That's what they call double layer.
Yeah.
Okay. Obviously, it's more durable because it's physically thicker. The material, there's an extra skin on it. It's stiffer because it's got that structural piece on top, and it's heavier because, well, there's more material. Okay, so that was double layer. Now that started to perform like people wanted it to perform, but it was heavy. Obviously, if you're trying to carry that on your back, you're trying to carry it down to the beach, that's not ideal. So then we were part of the pioneering element that said, well, can we put that layer and that layer together? That's when we started to specify MSL, because that is our own configuration. That's what we did.
And that is made before, at factory.
At the factory, yeah. Oh, when I say at the factory,
unroll it, and it's
higher up the supply chain.
Yeah.
So not at the fabrication stage, at the supply manufacturing stage.
Yeah.
But again, we're quite fortunate because we work with those guys as well, which is why we could do it. We don't just talk to our immediate factory, we talk up the supply chain.
It's easy to label something, you know. It's easy to give something a name in the marketing world, and MSL is our name that we've given to the material ultimately. But I think, as Phil says, people even at supply level want to be associated with being the quality, you know, the high profile supplier of a material. So from where I come at it in an MSL direction, we take on average 600 copyright claims of MSL down every year. Every single year, 600 copyright claims of people using the MSL term. So whilst, yes, it's a term that we've given to it, it's a term that the industry's picked up on as a sign of quality. And that's not necessarily because, that's not, again, marketing teams picking up on that and trying to use it in their marketing. It's what's being given to them by suppliers who are trying to associate themselves with that level of quality. So that's where I think MSL stands maybe slightly different apart, in the fact it kind of created its own new way of thinking. Like it feels like it's kind of pioneered that space, and it kind of became the flagship for that way of creating very performance-led, rigid, stiff boards. So, yeah.
So that's a clear example of where you've had a big part to play with the material. What about we talk about how you're bonding the rails and making the board airtight? Because I know that's a very interesting topic, and I've spoken about that in several different videos, whether you're talking about gluing, welded rails. What is your opinion, because obviously you've done a huge amount of data, design, number crunching about why you put stuff into production, because you guys don't use welded rails. What is your take on it? Why don't you use welded rails? Pros and cons. Let's
get into welded rails.
So fabrication is key, because it's not just about the ingredients that you're using, it's how you put them together as well. Yeah. I could give you a certain amount of cooking ingredients, I could have cooking ingredients, and whoever's the better chef comes up with a better product. Tech Air is what we've called our process. Again, we were quite fortunate because we made a lot of mistakes really early on. And as such, we've been able to refine that process with our standards that I mentioned. And the fabrication is equally as important, if not more important, because we're working with a composite. Composites are not easily recovered. So we need to make sure that our products last as long as possible, because they need to be as useful as possible and add value and help people. Okay. If they break, if they're faulty, if they're to a poor standard, they're not helping people get out on the water. We failed. So we consequently have done a lot of research into bond strengths, fabrication methods, making sure that we can make a product that's robust. So when you start talking about welding and gluing, at the minute we don't use welding. We can do, we've been able to do welding for quite a while, but when you're making a paddleboard, in particular, it's a handmade product. There's a lot of skill that goes into that, and we've been quite fortunate because we've retained a lot of our skill and workforce, and they've evolved as we've evolved. when you make a welded product, a weld is the application of energy to two similar materials that can bond those two materials to make one. Welding is a very strong process. It's often more strong than the actual material itself. Because the material moves in different directions, if you weld it and the material's not right, so for instance, in the case of a paddleboard, if it's let's say a U-shape, a banana, or twisted, or if that was metal, you could grind off a spot weld. A spot weld is when you tack a weld to make sure that everything's aligned, and then you'll seam weld to make sure it's strong. You can do that with metal. You can't do that with this material. You can't spot weld and then grind it off. So when you make a welded board, it's got to be right the first time.
So they start at one end,
Yep.
and they go right round back to that end.
They seal it back up. Great, fantastic, super strong bond. But again, it's also relying on skill, because it's a skill. Like any welder, any commercial metal welder will tell you, the materials are cheap. You're paying for the skill and their time. Now, when you get a welded board, it's often been welded because their gluing and their fabrication techniques and their chemical monitoring for the additives and the adhesions and the times, they don't know what they're doing, or they're unsure about it. So they're welding it as a safety, because they do want to make a product that lasts. If you get a product that's not right, there's two options. Continue to sell it, or landfill it, put it in the bin, because that board you can't use that board. That's mainly the reason why we've opted not to use it, because it does perform well, but we can create a much better board and a stronger board at the moment with the technology that we've got available to us because of all the testing that we've done.
That's what I think where we hung our hat on early doors, isn't it? You know, Tech Air originally was very much around actually how long the boards will last, the durability of the boards, to create that rail shape. Because I remember early on, even starting at Red, at shows and events, we used to deflate the board to 1 psi to show the structure of the board. Because it will look, that board there could be inflated to 1 psi or 20 psi, and you wouldn't know because it holds the structure. Whereas if you don't have the rail structure, it just would collapse in on itself. And that was always really early on we hung our hat. But from a glue point of view, yeah, I mean, you'll be able to speak, but we work with specific chemists on that point, don't we?
Yeah, we know teams of chemists, and I do anyway, and we do a lot of testing. There's shear testing, tensile testing. You need to make sure that the glue and the bond is not going to let go. There's processes, there's clearing, there's priming, there's cementing, there's time frames, there's pot life, or it's not half life, but when you create a cement or a glue, its gluiness deteriorates over time. So you need to make sure that the peak adhesion is when we use our glue. Humidity, temperature controls, all these different factors need to be taken into consideration when we're measuring and weighing and planning our glues. We do it exactly. We don't just make a big batch in the morning and then just use it up, and when it's run out, do some more, which other factories most likely do.
Because all this will make your board last longer.
This is why we do it.
This is the whole point.
This is the whole point, is because we need to make sure that these boards are as the best that they can be.
Yeah.
And that's one of the reasons, because again, the adhesion properties are great, because you've got to make sure that the seam stuff, because if a seam goes, well then that's a catastrophic failure. You need to send that for professional repair. And if that's not possible, you can either try and repair it yourself, or it's got to go to landfill, which is not acceptable.
And obviously when you're going out to China next week, aren't you?
Yeah.
So when you're out in the factory, it's very easy to see what's going on.
Yes.
How do you keep a check on that if you're not there? Have you got?
Well, COVID was tough.
So how often do you go out to China?
So I was pre-COVID. I was out there about 5 to 6 months a year.
Okay, so it's half time. And then and obviously you were saying you have a good, strong, understanding, respect with the factory, and they do to you.
Yep.
And is that the main thing that keeps your boards? How do you know that level isn't slipping when you're not there? That's the thing. It's just like
we do.
You can't watch every single board that's being made, can you?
No, exactly. And the when you're looking at QC production, you put in processes and practices to make sure that with design you have to design out potential for error. So I mean, it can be something as simple as making workstations so that everything is within arm's reach, or they don't have to travel or touch it once when you're manufacturing something. And that's things, again, that's all part of tech air, because you don't control, but you point them in the direction that you want.
It's a process, isn't it? You have a process that works.
And it's that sort of stuff. It's how is that material being cut? How is it being transported? How is it being stored? Where is that accessory? When that accessory comes in, how many checks has it had? It's the same with manufacture of when we're doing injection parts. What's the setup? What's the machines? What material? Who's the material? How is it being dried? Where's it coming from? How much recycled content's coming into it? All these sorts of questions.
Everything you just said is something when somebody buys a paddleboard, they have no idea.
To be honest, I didn't. Before I started working at Red, and even really years in, when you start to really get into under the skin of it, they're handmade products, and most of the stuff we come into interaction with is actually made now by robots. But handmade products is skill, and it's craftsmanship, and it's knowledge passed on, and that's it feels the same from a supply chain point of view. The reason why there's so much trust there is because we've been working with them since 2008, the same team, day in day out. Again, back to actually the Welded question, you almost don't see the need to it because of what we're trying to create in terms of the quality of the actual conception of a board. Yeah. And as everything that Phil was just talking to in terms of the supplier chain, there's a massive element of just relieving the pressure as well, in the fact that because we work with our suppliers and they're a private facility to us, we can do things like implement day rates for employees. Yeah. So it means that they're getting paid a day salary and a day wage. So they're not focused on...
They're not worried on making
a number. Because any other factory is going to be based on something called piece rate, where they can just make as many boards as they can because they're going to get paid by the number of boards they've made in that day or in that month or whatever. Yeah. What that then does is, okay, well, how do we create efficiencies? Because if me as a competitive person is given the task of, okay, well, the more you make, the more money you're going to make. As a competitive person, whether you're driven by finances or not, you're going to go, well, I want to make as many as possible. So where do the efficiencies come from in my day? Well, in that case, I'll make a bigger batch of glue. Because rather than having to get up off my workbench and go and mix up some more glue, which is actually quite a technical process with scales and weighing and that sort of thing, I'll just make a bigger batch. So again, that half-life of glue, it ties quite closely. So suddenly all these efficiencies start to knock on, whereas we relieve that pressure because we just go to day rate, which means that suddenly you're making a board based on QC and checks rather than
otherwise it will fail.
Speed. And there's a human element in there, isn't there? There's a
you could have an off day.
People,
we all have off days, and it's putting in those practices and those processes to catch those off days. But we're quite lucky because we really look after the factory, really looks after the workforce, and off days are few and far between.
Yeah, like you said, you were lucky enough to be making issues early on when you weren't selling as many boards. So if you suddenly made a mistake now, you've got 20,000 boards that are a disaster. That would be
exactly
more than a disaster.
Exactly, it's a lot of pressure.
So that's why your warranty rate now is so low.
Yeah,
but you're admitting you have made mistakes in the past.
Loads. And also, it's almost like a more human element. I've got two young kids, 3 and a 1-year-old. You've got same deal. At the end of the day, it's an inflatable vessel that can go anywhere. Like any body of water, someone's going to take the board out of. We need to be able to sleep at night. Yeah. Ultimately,
it's got to be good.
I want to be able to take my kids on it, and if I'm not on it, be able to put them on it, and know that they're absolutely safe. And because I work so closely with Phil, and see the work that goes on, that's such an important part of it because you're putting so much pressure. You've said if you could hear one of these boards when they're inflated, if they had a mouth on them, they'd be screaming because of the amount of pressure that's in them. 18 psi, 20 psi, or even 15 psi. That's a lot of pressure. What's your stat? hanging a transit van off a square inch or something.
It's 3 tons per square inch at the minute.
Yeah, that's a massive amount of force going on the rail tapes. That is.
Yeah.
But again, I know that.
What do you test your boards to? Because obviously you put more than 50. You've tested them to more than 15.
You should never inflate a board more than 22 psi.
But what have you tested?
So
Yeah. What have you done? I don't know.
Never inflate a board more than 22 psi.
No matter what board it is.
No, I would not inflate any other board more than that, because I've got to be fair. You can't say, oh, we're amazing, everybody else isn't as good. I think our products are the best because I know what's gone into them. And you should never inflate our boards over 22 psi, and I would argue our boards are the best.
And if I accidentally inflated your board over 22 psi, what pressure could I get to before it explodes?
We haven't ever exploded one. And not as in like just from air pressure, you know, like you get a roll of brand new one out and then it's like, we've never done that. We have had people leave them on, like through customer services, people leave them on compressors, for example, because, you know, we work with schools, network of schools all over the world. So people leave, the instructor leaves it on a compressor. They've got to go up to like 50 psi. But as Phil said, that's like a ticking time bomb. You don't want to get close to that thing.
It is dangerous.
That'll blow your eardrum out.
It's dangerous. Well, it could kill you. Because if you think about it's energy.
Yeah.
You're storing energy. It's contained energy, and this is why it's so important.
And when we're talking single layer as well, just to emphasise that, when we're talking single layer boards, you're talking about energy with, sure, there's this knitted or woven core, but then it's like party balloon thickness.
10 millimetres of joining rail.
Yeah, exactly. And then rails are even less, but then the actual surface itself is a party balloon.
But if it's next to
thickness,
something, that's what you've got to think about. I mean, it's like the old adage of if you have a firecracker on the outside of your hand, you burn your hand. If you stick it in your hand, it blow your hand off. I mean, it's potential. And I think that's the thing, is because one of our core values is integrity, and we've got to, like George has said, it's got to be right. I mean, it's just that behaviour that has set us above others, I would argue.
That comes into things like process as well, and I know you guys have talked about it in the past around glue lines on boards and stuff, but the reason why a lot of our processes are as they are is to avoid future potential issues that arise as a result of trying to deliver a perfect, aesthetically a perfect product, because if you do that, you're potentially creating a future problem. So glue lines is a very good example of that.
Yeah, so let's recap if the guys haven't seen that video. I remember we did a highlight and there was a small glue line around the fins or any rails. And I remember asking you, why is there because there wasn't before, why is there a glue line now? And you said,
you can have solvent creep. Yeah, so I mean, so when anything goes yellow, because the sun is the giver of life, it breaks molecules, it breaks everything in part, and it exposes. That's when things get discoloured. When you can clean a board, or you can fabricate a board, but if there's any solvents, they can creep under seams and they can move.
So this means that you could clean the excess glue off of that board and make it look
stick the rail around the
perfect.
outside.
Yeah, look.
Yeah. But then that solvent that you've cleaned the glue off
could
with
still be going.
Could seep underneath the rail and start to dig over years.
Over time.
It's a bit like rust. You know, it starts off as nothing to report basically, and slowly erodes, gets into the material.
That's what we found, and again, it's about making sure that these are as good as they can be.
Yeah. So you've got you said about the MSL material. You've got your new MSL 800. Yeah. Is your compact range, is that a unique material to you, or is that another material like a TPU based material, or other brands have got them?
So we specify our materials.
Okay.
Because we can start with stock materials, but we'll tune them.
Okay.
The compact range was interesting because that really kicked quite a few material manufacturers into touch. So when we started developing the compact years ago, the materials that I needed didn't exist, which is why you may have seen several years ago all of a sudden 1 or 2 different materials came out. that's because I was asking questions, or we were asking questions, to try and achieve something that I wanted to achieve. And that's why the technology just propagated. I mean,
yeah, because we've definitely got some more other brands, and you guys are more supple, softer,
yeah.
PVC based.
Well, this is the thing.
Okay,
So you've got the drop sit, and then you've got the PVC. You've said, like you said, you've just got TPU. There's different laminates materials that you can put on. They're different coatings. So they're the materials. That doesn't necessarily mean the woven or the knitted material is different. It just means the coating's different. Yeah. So that's the difference with the coatings that you're talking about.
It's also interesting that you said, now you said it, when you were doing the compact stuff has changed and filtered down to other brands.
Yeah.
So this is the thing as well, it's not just, you guys aren't just benefiting from this. Other people are benefiting, like the F1 team, F1 isn't it?
That's exactly what it is.
Yeah.
And again, I said to you earlier, I don't want it to sound egotistical, but that is what happens. I mean, we're fortunate to be in the position that we've been in. I mean, through a lot of hard work. But a lot of other brands out there, they will, after a certain exclusivity agreement or manufacturing agreements, after they expire, all of a sudden certain manufacturers will be able to say, we've got this material available.
I think it's from a material point of view, why as well? Because there's a lot of need in a lot of industries just to innovate, just to bring something new to market. But, you know, coming at it as a paddler, I very much come at it in terms of, this is what I like from this type of board, you know, this shape or whatever. And so the materials that are being introduced to answer specific reasons or paddler needs that they may want. So the compact came from that desire of, okay, we want a smaller, lighter, more transportable board, at the same time as answering that B Corp goal of reducing the carbon output from a board in terms of shipping and things like that. And so then that goes back to drawing board. MSL 800 on the new boards this year, so the Sport Plus and the Elite boards, that came from, we want to reduce the level of fatigue that a heavier board can generate over longer distances, increase the acceleration. As a result of that, actually, we've increased the stiffness, for example, on the board. But that wasn't the initial plan. It came from a paddler feeling, a paddler brief of what can we do here to improve the paddling experience, and that's kind of where it comes in. So, yeah, it's not just innovation for need of bringing a new product, it's coming from a genuine passion or desire to want to create a shape. And that's the other thing as well, it's very easy to create an inflatable board using off-the-shelf materials, but actually, is that what people need? You know, do people need all-round boards that are 6 inches thick that are going to be unstable, have a high centre of gravity, you know, too narrow, give an unpleasant learner experience? I'd argue probably not. That's not what people want from getting out in the water for the first time. So that's where a lot of the materials come from.
Okay, so now I want to move on to innovation. And almost, some people think that Red Paddle Co. are not actually that innovative with certain ideas. But I know you have got a lot of ideas that they're on the cutting room floor, let's say, they haven't even come out to light. Where is it with innovation, materials,